Hello Math 8 students, this is Miss DeWitt. Today you're going to be taking notes on section 8.2.1. Specifically, we're going to look at the textbook problems 836 to 840 and then 842 to 844. In 836, we're asked, is 3 to the 5th power the same as 3 times 5? And the answer is no, because if you do 3 to the 5th power, that's multiplying 3 times 3 times 3 times 3 times 3, 5 times. Whereas 3 times 5 is just 3 once and 5 once, which is 15. Where 3 times 3 times 3 times 3 times 3 is actually 243. So two totally different numbers. So no, not the same. When we talk about exponents, what we're doing is we're repeating multiplication. So on 837, they give you the table. So go ahead and copy this table down for me. They give you the original form. They ask you to write it as the factored form. And then they ask you to write it as the simplified exponent. We'll just say simplified form. So the first one is, I don't think I gave you enough spaces. So the first one is 5 to the 2nd power times 5 to the 5th power. So 5 to the 2nd power is 5 times 5, and 5 to the 5th power is 5 times 5 times 5 times 5 times 5. So you have a total of 2 5s and 5 5s, so that's 7 5s. So you would write it as 5 to the 7th power. If we look at another number, let's say 3 to the 7th, no, let's do x's. Let's look at it with variables. So let's say we have x to the 3rd power times x to the 5th power. We would have 1, 2, 3 x's, and then we'd have 1, 2, 3, 4, 5 x's for a total of how many x's? We'd have x to the 8th. Are you noticing a pattern here? Let me show you one more. Let's say you had x squared, x to the 3rd, y squared, x, y to the 2nd. So what this is saying is you have 3 x's, 2 y's, 1 x, and 2 y's. So you're going to group the like variables together. So you have a total of 4 x's, x to the 4th, and then another 4 y's. So you would have x to the 4th, y to the 4th. So what this pattern shows is that when you multiply in the same base, so when we had our 5 and our 5 as the same base, you need to add the exponents. And that's how we got the 2 plus 5 gave us the 7. The 3 plus 5 gave us the 8 when the bases are the same. So let's think about this problem, for example. Part B says to visualize, we're not going to write all these out, but 20 to the 12th power times 20 to the 51st power. So that would be 12 20s times 51 20s. Well, really what's happening is we're taking 20, keeping the base 20, and we're adding 12 plus 51. So that would be a total of 63 20s. And then you work that out, it'd be a really, really big number. So let's jump down to 838. Let's say we have 3 times 2 does that equal 2 times 3? It does because of something called the commutative property. The commutative property of multiplication, states that you can move, as long as you have multiplication and only multiplication, you can move numbers around and the answer is always going to be the same. Because if you multiply 2 times 3, that's 6. If you multiply 3 times 2, that's 6. And you multiply 2 times 3, that's 6. They're the same answer. So you can move numbers around without ever having to really change, never changes the answer. So if, for example, we give you 5 squared times x to the 4th, and we times that by 5x. Well, here's what's happening here. I only see multiplication. 5 squared is 5 times 5, even though it's an exponent, it's just 5 times 5. X to the 4th is like having 4 x's. And then you have 5x, which is just 5 times x. Well, how many 5s did we have here? We had 1, 2, 3. So we would, I wanted to use a highlighter there, but I didn't. That's okay. So that would be 5 to the 3rd power. And then how many x's do we have here? We have 5, so that would be x to the 5th power. And the simplified answer here is 5 to the 3rd, x to the 5th. That is how you simplify an exponent expression. All right, what about this one? Go ahead and you try this one. Pause this video after I write it down. So you have 3w squared times 3w squared, and the first one actually is a 3w to the 3rd, times 3w squared times 3w times 3. So pause this and try this on your own. So I'm going to say I have 1, 2, actually let's write it all out. So 3w squared is 3 times w times w. 3w squared is 3 times w times w. 3w and 3. So I have 1, 2, 3, 4 w's, so that would be 3 to the 4th. I have 1, 2, 3, 4, 5, 6 w's, so that would be w to the 6th. And so that would be your solution. All right, so we're going to jump over here and we're going to talk a little bit about scientific notation. So scientific notation is a form of exponents. If we're looking at problem 8-39, they give us the A, they say 9.23 times 10, and then B is 9.23 times 10 to the 3rd or 2nd, and then C is 9.23 times 10 to the 3rd. So 9.23 times 10 is just 92.3. 9.23 times 10 squared is 923. And this ends up being 9,230. So what happens when we multiply by a power of 10, and I'm going to put 10 to the x, you are moving the decimal the x number of spots, right? Because when this was a 1, we moved it 1 spot. This was a 2, we moved it 2 spots. This was a 3, we moved it 3 spots, and we added a 0. So when you multiply it by 10 to the x power, you are adding you move your decimal x places. And then in this case, when the number is positive, we're going to move it to the right. And then when the number is negative, we're going to move it to the left. Okay. So let's take a look at 840. There's some practice there on 840. So 8-40 for A, they give you 78.659 times 10 to the 2nd power. So because we have a 2 here, the exponent of a 2, we're going to move our decimal 2 places to the right. Make it bigger. So 7865.9, which is 7,865.9. Problem C, I'm going to jump over to problem C. 1.39 times 10 to the 6th. Now because it's 10 to the 6th, we're going to move our decimal place 6 places, but we only have 2 places with numbers in it. So we're going to add 4 more zeros. 1, 2, 3, 4. So we have our 139 and then our 4 more zeros. And let's just double check. 1, 2, 3, 1, 2, 3, 4, 5, 6. Perfect. And so that is our solution. Okay, so scientific notation. Here's what you need to know about scientific notation. Scientific notation is a number times 10 to the x power. I'm sorry, let's say to the n power since we're using that multiplication symbol. To the nth power, where your number is greater than or equal to 1. So it's got to be greater than 1, but it also has to be less than 10. So there's this very special window. And n is a positive or negative integer. And we'll talk more about what happens when it's negative in a minute. So let's take a look at some examples there. So let's take 842a. You have 25.6 times 10 to the 4th. Now, the 25.6 is not between 1 and 10. So what we need to do is we need to rewrite this so that this number is moving 1 to the left. Well, when we move something to the left, we're making this number smaller. So we have to make this number bigger. So it's going to be 2.56, but in order to keep the number itself, we got to make the 5 larger. For part B, we have 5.46 times 100. Now this is good. The 5.46 is good, okay? Because it's between the 1 and 10. What's not good is the 100 because it's not an exponent of 10. So we need to write that as 5.46 and 100 is just 10 to the 2nd power because it has 2 zeros. All right, so what happens on 8-43 when we're given just a number? And the first number we're given is 570 million. And so we need to put a decimal so that it is between 1 and 10. So the only place I can put my decimal is after the 5, so 5.7. And then I need to multiply it by 10 with some sort of power. Well, if my decimal's here, I have 1, 2, 3, 4, 5, 6, 7, 8. So that should be times 10 to the 8th power. So then, if I'm looking at part B, and we have 48,710,000, go ahead and try that one on your own, and you should get 4.871 times 10, and I have 3 zeros here, 6, 9, 10 times 10 to the 10th power. All right, Math 8 students, so go ahead and check your playlist and get working